Assalamualaikum. Before we go to our presentation, I would like to introduce our group members. I will start with myself first. My name is Nur Arina Syaira binti Ibrahim, and this is my group members, Siti Hawa binti Rosli and Fatisha Zana binti Khairul Amali. So today we would like to present about our assignment 1. Okay, firstly we have designed a simple neural network, which is to find way to get the decision plan, and then we use Microsoft Excel and MATLAB software. And this is a Hebbian and Adeline formula, which is the algorithm that we use. And we will go through the demonstration one by one. So I will pass the first demonstration to Siti Hawa.
Assalamualaikum, my name is Siti Hawa binti Rosli, and I would like to present the demonstration of the Hebbian by using Excel. Okay, so this is the input given, so x1, x2, x3, and while the t we assume at the class A 0, 0, 0, while for the class B is 1. Okay, so this is the assume of learning rate n 0.1, bias B 0.5, weight 1 W1 1, weight 2 W2 is 1, while the weight 3 W3 is 1. Okay, so first of all, we construct the table of top to bottom. So this is how the table we do in this Excel. Okay, so for the Hebbians, the input and the t and y. So for the t and y, as you can see, the output will be the same because of t must tally with y must tally with t to get the accuracy of this algorithm. Okay, so for the to find the W1, W2 and W3, we follow the formula of Wn equal to W0 plus n times x times y. Okay, so I explain how to the doing the algorithm equation. Okay, so this is the equation. Okay, I show the example. So the Wn to find the W new equal to W0 plus n times x times y. So we select the column of W old. Okay, then plus which the n, which is 0.1, times the x is this column, W1 and W1 and x1, so this column. Okay, times with y. Okay, times with this column. Okay, as you can see in this column we cannot select. Okay, just follow the coordinate of F14. So F times with F14. So just enter. This is the result. So the same step will show the result. As you can see the table, we get the lastly 1.3, 1.2 and 1.2 the weight value. So to calculate the bias is the difference formula, which is bias old plus n learning rate times y. Okay, I select for the example. So this is the equation. So to find the bias, so bias old, just click the column plus n times with the y. So this is the column, right? Okay, so this is the line of the y. Okay, so just enter. So this is the result. So the same step will show the result value. So for the class A, we'll get the bias 0.5, while the class B is 0.6, 0.7, 0.8. Okay, next for the calculation, for calculate the accuracy, to get the accuracy 100% is we must total it, the weight and the input value. So this is the calculation So this is the formula given. So I try to do a simulation. Okay, sorry. Okay, so x1. Okay, we follow the formula. So we follow the formula. So the so x1 times w1 bracket plus x2 bracket plus x2 times with w2 plus x3 plus x3 times with w3. So tutup plus with the bias. Okay, so this is the result. So see, the result will remain the previous because of the calculation using this formula. Okay, so to find the accurate of the 100% is when class A is below than the theta value, so they will get 0. So when class B is above than theta value, so they will get 1. Okay, as you can see, the equation is if F24, this one, less than 2.5 will get 0. So else is 1. Okay, so else is 1 lah. This for the class B. Okay, so to find the theta. Okay, to find the theta, we use the formula is. So we use the formula is when so for the class A is choose the highest value while the class B is the less value. Okay, so the 3.3 minus 2 divide by 2 plus which the highest of class A. Okay, so they will get the answer 2.65 for the theta. So when x2 and x3 is 0, so they will get the value of x1. And the theta value, the column of this, minus by 0.8 divide by 1.3. So the same step in this x2 and x3. So x1 and x3 will become 0 when x1 and x2 is 0. So they get the value of x3. So next for the bottom to top. Okay, so bottom to top we shuffle the input so from bottom to top. So the T and Y also we shuffle. So as you can see in this figure, such as the previous. So the same step by using the formula. So as you can see in this column, in this last column, W1, W2, W3 and the bias is the same with the top to bottom. 1.3, 1.2, 1.2 and 0.8. So as you can see, the same value. So if the same value, we just follow and the answer will become the same. So we just follow the step, so the answer will get the same. So we find the sum of the y value. So if y is above than if y is above than 2.65, they will get 1. Okay, so this is the same step with the previous. Okay, then after we calculate the x1 bar, x2 bar and x3 bar, so this is the boundary decision 3D scatter plot. So we want to create a 3D plot. Okay, so this is the coding of the 3D plot. So firstly, this is the input of this process. So however, we must comment the scatter tree X, Y and Z in fillet. So fillet is this one, the boundary decision. So then we just follow the existing coding and we insert the x value, the new x, so which is 1.42 while y is 1.54. So in this column we insert the value of x, y and z. So this is the x1, x2 and x3. So this is x1, x2 and x3. So this is x1, x2 and x3. So this is the value of the new x. So we assume x, y and z. So the title boundary we create for the title boundary decision. So x label we assume as x1, y label we assume as x2, z label we assume as x3. So we run the program and we get the figure of this value of this diagram. So this is the 3D plot its look. So where to find the value is in the corner. So this is the value of x. So while this is the value, this one is for the value of y. So the x and y is tally with the calculation of the boundary decision in Excel. So the diagram will be like this. Okay, that's all from me. Thank you.
Okay, hi, Assalamualaikum. My name is Fatin Shazana Vitika Ramali with NAFID number DE170079. So my part, I will explain about Adeline training algorithm in solving the linear problem. So as you can see here, the table x1, x2, and x3 is a given sample, and then for the key value, I just take the assuming number with different classes, which is A000 and then B111. So let's see to the Excel part. So this is the calculation that I do in Microsoft Excel. The first table here, as you can see, this is linear problem that, as I said in the previous presentation. And then the next one, this is the parameter used in Adeline algorithm. So for the learning rate, I just take an assumed number which is 0.1. And then for the S parameter, I'm using Adeline parameter, which is x1 w1 plus x2 w2 plus x3 w3 and then plus all bias. And then for the new weight parameter, which is the O weight plus learning weight times initial x, which is in here, and then times to t minus s. And then for the new bias, which is BO plus n times t minus s. And then for the data, I'm taking the value, I'm using the parameter by taking the value of the highest value of classes A 000 and then the lowest value for the Y111. And then for the weight sum, x1 w1 plus x2 w2 plus x3 w3 plus bias. This is the parameter that I'm using for in this column, in this row. Okay, let's see for the network performance. There are two network performance, which is first one is top to bottom, and then I retrace it to the bottom to top. So there are 6 iters here, and then we have the x value here, and then I need to find the s value, t minus s value, w1 value, w2, w3, b, and then weight sum, the new weight sum, and then I have to compare it if there is 100 accuracy. So here, for the s value as the previous parameter, I'm insert the formula in the table. So as you can see here, the yellow one is D26, 0 times 1. The green one is 0 times 1, and then 0 times 1 plus b, 0.5. So I can get the value. Same goes to the others. And then for the t minus s, okay, I'm using the formula. Insert the formula t minus s, and then insert the formula for w1, and I can get the value here, the answer. Same goes to w2 and w3, and then the b value, I'm using this parameter, which is 0.5 plus 0.1 times with t minus s, and then this is the weight sum, and I am compare it. As you can see here, if n26 and 26 is negative 0.1 less than 0.893, it will turn to 0. So, and then what happens here, okay, if 1.887 is less than 0.893, so if it is not less than 0.893, it will turn out to be 1. So I do the same formula for the bottom to top. And then, so as you can see here, both of these table, which is top to bottom and then bottom to top, have 100% accuracy. And then the next one is boundary division. This is to get the value of boundary division, to get the value in MATLAB later. So for the x1 value, I'm using the parameters of theta minus 0.1 divided by w1. This is for x1. And then for x2, I refer to the color. So theta minus bias negative 0.1 divided by K31 0.619, referring to W2. And then same goes to X3. And then same goes to bottom to top for X1, X2, and X3. So the next part, I will show on how the MATLAB process in getting the division boundary with scatter plot. Okay, now I will present on how I get the boundary division after I do the calculation and get the value in the Excel. So I will open the MATLAB software. Okay, as you can see here, this is the coding that I'm using to display the scatter plot and also the plane on division boundary. So this is the input x0, x0, y0, z0 for item 1, x0, y1, z0 is for item 2, and then for item 3, item 4, item 5, and item 6. So this is for the input. And then I insert the x value, the boundary division for x value, and then also the y value. So I run this program. After I run this program, it will show this figure. So it will show this figure. As you can see, the dotted one is the scatter plot for the input. So this one is 0, 0, 1, 0 for the item 2, 0, 0, 0, item 1, 1, 1, 1, item 4. And then for the plane, okay, in this coding, I put the x axis with 1.368. So as you can see here, the x is 1.36, and then for the y is 1.604. Okay, this is because I plot in the not near. It is I plot near to the edges of this plane. So this is the 3D scatter plot. So this is the x1. X1 is for x, x2 for y, and then x3 for z. I try to rotate this. So this is how it looks like, where the scatter plot is plotted uh, on the on its position, on its axis. So that's all for this MATLAB software for Adeline algorithm. Thank you.
To be conclude, we're able to solve linear problem with 100% accuracy. We're able to know the difference between retained data and the original one. And we're also able to use both Microsoft Excel and MATLAB very well in doing the training. So that's all from us. Thank you.